Now, are you ready to find out how and why networked intelligence, Slime Mould, is more intelligent than you? Yes, you are. Can we welcome, please, Danny Nemu?
Slime Mould, everybody. Hello. So you've just been hearing a woman talk about how stupid her dog is. I'm now going to tell you how intelligent my protist is. Have I offended a dog lover already? This is a slime mould, and these are some slime moulds as well. I'm going to pass them around. Don't eat them, but they are living creatures. They're protists. They're kind of a cousin of amoeba. I'm going to show you some dried ones in a minute. There we go. So you can just pass them around. And I'm going to tell you all about them. So networked intelligence in nature, how slime moulds are cleverer than you. Slime moulds are single-celled organisms, and they're about 400 million years old. And this is what they do. They kind of spend most of their time spreading out, finding food, like the rest of us, really. But they collectivize in a really interesting way. So bear in mind, these guys have no brains, they have no nervous systems. You can't even see them without a microscope when they're in their individual state. But they live on logs. They live on wet logs in the forest. And when their logs dry out, then they do something amazing. They come together into these kind of mushroom-looking things. They're not mushrooms because they're not fungi. They're protists. They're protozoa. And so they make these towers, and then the towers burst in the same way, like similar to mushrooms, and they spore. And obviously they're not spores because they're not mushrooms. But the spores can then get onto the air currents, and they can get onto the wings of insects that are going past, and they can go somewhere else where the conditions are better, which I find is quite amazing. But they do all sorts of other things. They collectivize in other ways, and they respond to their environments in really interesting ways. So, for example, why am I talking about slime moulds? Actually, I should introduce myself. My name's Danny. I run a CIC. I run an organization, and we do reforestation in Brazil, and we do all kinds of landscape regeneration projects. And we're inspired by these creatures, by slime moulds, also by mycelia, by which I mean we kind of learn how to do our thing with these guys. I'm going to pass around some more, actually, which are dried ones. These are sclerotia, so you can pass them around as well, and I'll explain what they are in a minute. They're not poisonous or anything, but they're not generally eaten. Anyway, they really like oats, and if you put oats in a maze like that, they will find the most efficient route in the maze between the oats, which is quite amazing, again, seeing as they have no brains or nothing like that. They solve mazes better than 4-year-old children, and I would wager better than that dog that we just met. So they're very good at mapping space and transferring resources around that space. And they're also, so this is a slime mould expanding and connecting up these oats in a super efficient way. And these oats are in the positions of the Tokyo train networks, stations. And if that took 23 hours, and they outdid the Japanese, this is a more efficient network than the actual Tokyo network. One very interesting thing about the slime moulds, and Japanese actually, is most of the slime mould research was done by Japanese people, and they have a very specific collective intelligence. I lived in Japan for 6 years, I can say that kind of thing. Japanese really know how to collectivize and how to see collective intelligence in nature. Right, so they map space, but they also map time. If you blast a slime mould with cold air, it will retreat, much like most of you probably would. And if you blast it for 5 minutes, it will retreat. You can see that here. If you wait an hour and you blast it again with cold air, it will retreat, but it will retreat further. And then if you wait another hour and you blast it with cold air again, it's already retreating 5 minutes before you blast it. So they're predicting rhythms in time even before it happens. On 2 instances, they can already guess when the 3rd instance is. It's a little bit like when you wake up just before your alarm clock, which I occasionally do. But these guys do it with some regularity. And they'll even remember it for the next hour. If you don't blast on the next hour, they're already retreating. Then they realize that there's no cold air, they're not being tortured. And then you can stop for a while. If you start again 8 hours later, they'll remember the whole sequence and they'll go back into that retreating sequence on the hour, which is pretty incredible. How do they do this? We don't know. We've got no idea. It seems to be somehow related to how they network. I don't know if you saw the image of how they kind of network. The way our own brains predict rhythms in time, like predict a beat in music, seems to be connected to how the neuronal charges go through cycles in kind of complexes of brain cells. So these guys, they move around, they have cytoplasm moving backwards and forwards, and they're pulsing as they're moving and growing. And in fact, the cytoplasm that moves inside them is the fastest measured thing in the microbial world. It moves at 1.35 millimeters per second, which is really fast. And these guys themselves, they grow at the rate of about 1 inch an hour if you really press them. So what do we see here? We're seeing anticipation, we're seeing memory, we're seeing recall, we're seeing learning and adaptation. It's pretty mind-blowing. Let's talk about salt. If you grow slime molds in an environment where there's salt, slime molds, like all protists really, they don't really like salt because it dries them out, so they keep away from it. But these guys can learn, if you put food on the other side of a salt bridge or a salt barrier, they'll make a bridge over the salt, or basically they'll go through the salt and they'll take the damage that entails to some of their members, and they'll get to the food, right? And they, not only do they learn to do that, but this is what's happening here. So these slime molds, they've never seen salt before, and this one has, and you can see that they're charging across this salt barrier. What's really interesting about this is they can then go and teach other slime mold colonies to do the same. So you can dry these guys out, and when you dry them out, they become sclerotia, which I've just passed around. And you can wake them up 6 months later, a year later. In fact, there was one case in a lab where they found an old slime mold sclerotium, which was 60 years old, and they wet it, and it came back to life, and it went and did its thing again. So you can wake these guys up, and they will retain that information and then pass it on to other slime molds they meet. And then the slime mold that's never met a salt barrier before will know to cross the salt barrier. So how do they do that? Some people seem to think it's something to do with the memory of water, but these guys are drying out. Pretty amazing. I wanted to talk about cultivation as well. If slime molds find some bacteria that they can eat, they will eat some of it, but they might not eat all of it. In fact, what they might do is they might save some of it and cultivate it so they can eat it later, which is kind of like when you keep a couple of biscuits in the biscuit tin, which is something I've never managed to do. Yeah, so really clever guys, really. Just kind of summing up, what can they do? They respond to threats and they respond to opportunities. They redistribute resources and information. They perceive rhythms in time and predict the future. They solve problems in a harmonious way. And they guide individuals towards harmonious action. Now, we know what they do in terms of predicting rhythms in time, predicting mapping out space, how they learn certain things, but we don't really know very much about what they do in the wild. So it's fairly new science, and what they're capable of when they're outdoors is anyone's guess, really. This is Physarum polycephalum, this particular species, and there are loads of species, and some of them look really, really pretty. I think this one's beautiful. Physarum polycephalum. I think that makes me a polyamorist. Why do they do this? For the resilience of the collective. They've collectivized together, and this is how they survive. And they've survived for 400 million years doing this. We've found, in fact, one of the oldest fossils amber fossils is slime mould, those mushroom structures in amber. How do they do this? Well, we don't know. On the level of the mapping, it might have something to do with microtubules and filaments, but and it seems to have quite a lot to do with how they kind of pulse as they move. But no, really, we don't have a clue, and they're quite unpredictable as well. They're like you can't really tell what they're going to do. I know quite a few people who study these things and they make artworks out of these things. One thing they do that's very interesting, if you speed up the kind of movements, they pulse like this. And so if there's a kind of advancing wave of slime mold, they pulse like this. And then when they decide they're going to do something else, i.e. they're going to either dry out into sclerotia or they're going to form those mushroom bodies, then the pulses change direction and they kind of start going in pulsing back towards the middle. So they're kind of conferring with each other in some way that we can't really understand. So they plug into a network and they become a superorganism. So what's that got to do with me? Why am I interested in this? Well, I'm really interested in intelligence and collective intelligence and leaps forward in intelligence. There was a guy called Bruno Latour. I don't know if you've ever heard of Bruno Latour, but he was the guy who came up with the term collective intelligence. And he talked about how when human beings develop new technologies of communication, then their intelligence leaps in a way that's completely unpredictable. So he gives the examples of, for example, language. So when we get language, when we get spoken language, we can articulate what's going on in our heads and we can share that with other people. And that levels up how we were as primates, and it leads to the whole development of a different kind of apparatus for articulating noises with our throats and our tongues and our teeth. And then when we get written language, you can not only communicate it, but you can fix it, and you can pass this information across time, and you can collect it together into libraries, and you can start to compare things. And then when we get the printing press, then you can start to publish it and put it out, and all kinds of massive changes happened in the Middle Ages, or the end of the Middle Ages, when the printing press came about. So we have this amazing moment in our history now where you can basically email the entire world. We have this new technology. And we are collectivizing, globalizing in a way that's never happened before. And I think we've got something to learn from these slime molds. So I want to talk about shamanism. Do you like my t-shirt, by the way? It's a slime mold t-shirt. Made that myself. And then I went to a party probably about 3 months ago. It was a 5-day-long party in Belgium. And I got so excited that I got a slime mold tattoo. Shamanism. I don't know if anyone's familiar with shamanism or ayahuasca. Last time I was here, I spoke about drugs in the Bible. I handed out some resins. People ate them. Don't eat my slime molds. Although people do, like back in ancient China, they used to eat them apparently. Anyway, so in shamanism, the point of a shaman, or the job of a shaman, is to protect his or her tribe from the various threats which they might face. So, for example, the traditional, I'm not talking about kind of Silicon Valley types going to, develop their Tai Chi practice in the jungle or whatever it is, up their game in the corporate environment. I'm talking about traditional shamanism here. So they were obliged to do things like respond to threats and opportunities. Now, those threats might be an enemy tribe invading. And how do they deal with that? Well, the shaman would take his or her mushrooms or his or her ayahuasca and then communicate with this greater network, communicate with the gods, and then provide military divination or military tactics for how to deal with it. Should we sue for peace? Should we run away? Should we attack? Other threats might be a disease in the nation. So they'd come up with cures for this kind of thing. Also opportunities. There are whole tribes where the only thing people, shamanistic practice, is concerned with is hunting. And in fact, so the shaman will drink his juice, go into a trance, commune with the spirits of the animals, and they will say, okay, you can take 4 monkeys and you'll find them by the river at this particular point in the afternoon. and they'll go, and according to their stories, and these are stories that I believe, they will go and find these monkeys. So this is a redistribution of resources around the jungle, and it happens after this encounter. Information as well. Shamans were traditionally tasked with finding lost objects as well, or finding out who had caused a problem in the tribe. Perceiving rhythms in time and predicting the future. So I have a really good story about this. This isn't actually what you might think of as a shaman, but I was in Kumbh Mela in 2001. Kumbh Mela is a massive 70 million people festival in India, and all the sadhus come down from the Himalayas. Really? Okay. And so there was a guy there who his followers had come with, who'd basically built a massive pyramid for this guy, like a 6-story pyramid for this guy. He was a tiny little skinny naked man in a hut. And the reason they liked this guy so much was because one day he came down from his mountain dwelling to the village. He said, "You've got to move your village from that side of the river to the other side of the river because there's a flood coming." And they did, and there was. And they weren't all washed away because they took the advice of this guy. So predicting the future is something that mystics, shamans, astrologers, John Dee, the Queen's astrologer, they've been doing that since ever. Solving problems, guiding individuals in a harmonious way towards kind of collective health. So again, in shamanism, you have brujeria or witchcraft, and you have shamanism. And the difference is a witch, and they'll use the same techniques, but they will assist somebody to the detriment of somebody else. And proper good shamans, or good shamans, will assist to the benefit of everybody else. How do they do this? They plug into a network, and they become a superorganism. A bit like the slime molds. So, yeah, that's more on... well, there's plenty of ayahuasca in that book anyway. But what I wanted to talk about was what's this got to do with what I do? So I run an NGO. We are called RAIN, and we work with land restoration, food security, reforestation, community autonomy. We work in Brazil with black women's groups. We work with indigenous nations. We work with formerly enslaved populations. And a lot of charity work is very colonial in its construction. And what I mean by that is generally what you'll do is you'll give your money to the charity, and they will distribute it to where they think is a good idea, which will make their supporters happy. And we kind of looked at that model and we thought, no, that's not really the way to do it. What can we do? How can we do this differently? How can we do this in a way that's equitable and horizontal and respective of community autonomy, right? So that's what we do. Why are we doing it? Because there seem to be all these problems in the world. Melting ice caps, changing weather, supply chain collapse, refugee crises. So we work in Brazil, and Brazil has a massive problem with hydrology because they've deforested absolutely tons of it, mostly to strip it for wood for our own consumption and for animal feed for our own consumption as well. So this seems like a Brazilian problem, but actually we're all connected because the weather patterns in Brazil alter the weather patterns in North Africa, which alters the food situation and the political situation in North Africa, which means, you know, they were looking at 40 million climate refugees coming up into southern England. Right? That's a problem for us as well. Right? So the slime molds know that they're all connected. Humans haven't quite worked it out yet. And this is why this is a particular model for us. Lack of leadership and a mental health crisis. So in the way I read the world, the grand problem that unites all of these various different minor problems is that we are disconnected. We're disconnected from each other, we're disconnected from nature, we're disconnected from ourselves. So this is why we have studied the greatest connectors that I found on the planet to work out how we might do things a little bit better. So this is the question I wanted to answer with this NGO that I started. Could the networked intelligence of a distributed collective respond to the collective challenges we fail to meet as individuals? Could the networked intelligence of a distributed collective respond to the collective challenges we fail to meet as individuals? So that is that network I run, along with my partners in Brazil and all over the place. So, I mean, what does that look like exactly? I'll give you an example, right? And I'm going to give you an example, actually, from the mycorrhizal root network, which is another network. It's how trees communicate beneath the ground through mycelial fungal strands. If a tree is attacked by an insect, why am I talking about mycelia? We're inspired by all kinds of nature's networks, including slime mold, including mycelia, including ant colonies, those kind of things. So if a tree is attacked by an insect, it will produce defense chemicals. And they'll take a few days to get produced, but it also produces infochemicals, and they pass through the mycorrhizal root network, so down through the roots, into the mushroom threads, the fungal threads, and off to other trees, where they warn the other trees about what insect it is and how to defend themselves. And then the other tree will produce defense chemicals as well. And they don't just warn their own species, they warn other species. So a Douglas fir will tell a spruce that there's a particular insect about, and then they should defend themselves. Why do they do this? Well, that means that when the insect can't eat anymore because the defense chemicals are in enough abundance in that tree, they'll go off to another tree, but they'll find it's already defended. So this defends the whole collective of the forest because of this communication of information. So what did I kind of learn from that, and how do we apply that? Well, I've been seeing, we applied it to media, because this is how do you communicate between species, right? How do you communicate to different places? Well, an infochemical does three things. Firstly, it spreads widely, right? Secondly, it provokes an appropriate response, i.e., if it's this insect, you want that chemical. If it's that insect, you want another chemical. And thirdly, it communicates with other species, right? So I've been seeing images of the Amazon burning since I was a child, and it hasn't provoked an appropriate response. It's just made me scared. I don't want to tell my mum about that, but I do want to tell my mum about, for example, some beautiful piece of media. So what did we do? We took a traditional song from an Amazonian nation, the Noki, recorded by the leader of this nation, played on flute and sung, and got it backed up by 2 London orchestras doing a classical arrangement of this song, and then we got it filmed in St John the Evangelist up in Norwood and got it projected onto the walls, or rather got Amazonian scenes of monkeys leaping from tree to tree projected on the walls. And then we got Miriam Margolyes, who is networked to me because she's a distant relative of mine who got in touch with me once upon a time and said, I'm a distant relative of yours, do you want to go for a curry? Okay. That's what she does. She kind of collects her family tree together. She's a very strange lady. But anyway, she did the voiceover for that particular piece of media, and we got it on Classic FM, we got it on Radio 3, and we were doing this about a particular tree called the Brazilwood tree. It's the resource that Brazil is named after. It was used as a dye for a red dye. It's a beautiful red colour. It was also discovered in the 1740s that it makes amazing violin bows. In fact, it's before the 1840s, the sound of the violin was more like the Mongolian violin, kind of screechy sound. But the particular resonance of this tree makes the sound of the violin which you're all familiar with. And this is massively endangered. There's probably about 5 to 10,000 of these things still standing. And a huge illegal trade in the bows. So we wanted to tell this story to people outside of the ecology community, particularly the classical music community, because, as I said before, and as we all know, we are all connected. And the classical music that you might think is quite far away from ecology is actually intimately dependent upon it. So that is a message that we could spread to other communities. That's a message that will provoke the appropriate response, which is, giving us money. That's one thing. But also changing how you might consume a bow. So, for example, looking into carbon fibres rather than an endangered species. So that's just one way in which kind of nature's networks can teach us what we're doing. So I am running out of time. Tim is looking nervous. So I will, what will I say? I will just say, if you're interested in what we do, if you run a business, please come and talk to me. It's called rainreforest.org. We're looking for support. And if you're interested in the kind of things that I say, I've written 2 books down there. One of them is about revelation in the history of science, people who discovered things in dreams and in hypnagogic trances and in flashes of inspirations, people like Tesla, people like Mendeleev, the origin of the periodic table. I could go on. And that green one down there is about what goes on in our minds when we see things, when we miss things. So it's got comparative linguistics in it, it's got psychology in it, it's got a whole load about neurodiversity. What different things in your mind make you see and make you miss, and how we can how it all influences our intelligence. I'm not going to talk about that. That's how we govern the organisation. I already talked about that. And that is the Trees of Music project, which I mentioned. And I've told you about all of this already. Thank you very much.
Danny Nemu.